So in this video, we're going to talk about a very nice concept in Java called polymorphism, and it allows us a lot of flexibility. So let's look at this code here. Let's assume, we didn't implement a computer science student object in our example, but let's assume that we did implement computer science student, which extends from student. Let's look at this code, what it's doing. It's creating a person object. Okay, so this is a reference. This is a variable person that is referring to a person object. And when it goes to actually create the object, what it's doing, it's creating a computer science student object. It's creating a child object. Now, is this going to be allowed? And the answer is yes, it will be allowed. Why? Because if you ask a computer science student or the computer science student object, are you also a person? It will say, yes, I am a person, because it extends student, which extends from the person class. So if I come here, let's go to this class. And here what I want to do is I want to create a worker, W equal to new worker. I also want to create a student. So let's import the student class because we're in a different package right now. And actually, I'm going to put an asterisk here because I want to import student and person, because I'm going to use person in a little bit. And I'm going to create a student as equal to new student cat 1. I'm going to create also a person P equal to new person. And let's see, do we have a person constructor that takes a string as input? We have one that takes a string, the name, and the social security number. So let's use that. So now we've created these three objects. Now, in memory, in RAM, what is happening is that we are creating a worker object, and then the address of this worker object, whatever the address is in RAM that got reserved to create this worker object, is stored in this variable W. So what is W storing? W is storing the memory location of worker. Okay? Again, S here is storing the memory location of that student. So all this variable is doing really is storing the memory location of this object. Okay? Of course, it has to be compatible. You can't just say, I can't say worker, let's say K equal to new student. That's not going to work. They're not compatible. Student and worker are not the same object. But what I can do is if I want to store a reference to a worker or a student, I can actually store it in a person object, because a person so here a student is a person, okay, because a student has all the features that are in person. So I can store the student object in a person. Okay, now the opposite is not going to be true. I can't say student, let's say SS equal to new person, and expect that to work. And let's just make sure we do have an empty constructor. We do, so this is not the issue. We do have an empty constructor, but here it's going to say incompatible types. Person cannot be converted to a student. So if you think about it, paint so we can draw. So if you think about it, a person object is storing the name and social security number. A student is storing everything in person, so it's storing the name because it's extending person, so it's storing that name. Of course, that information is stored in the person class, but it stores name and social security number where it got it from the person, and it's also storing the big banner ID. So if I want to kind of say this person P equal to new student, the student is actually a person, so you can do that part. Now the opposite way, if I tried saying student, let's say K equal to new person, okay, not every person is going to be a student. Okay, I can have a person that's a worker, for example. So not every person can be stored as a student. So, you know, out of person, we're extending worker. The worker and student are not the same. They're not equal. So I can't do that. So this is wrong. You can't do that. However, the student is a child of person. So you can store its address in the person object. So this is called polymorphism, where you can have this address take on different forms. You can have this variable person store the reference or the address of a person object, or it can store the reference of a student object, or it can store the reference of a worker object, because person is a parent class. So it can accommodate itself and it can accommodate all its children. Okay. The nice thing about also polymorphism, okay, so this is not going to be valid. The other nice thing about polymorphism is that you can store them like in an array list. So here I can say I want an array list, and I want an array list that stores my worker object, my student object, and my person object. Well, worker and student are also person. So if I create an array list of person objects, I can store in it person objects, I can store in it student objects, and I can store worker objects in it. Let's import our array list. So Java array list. So here, if I go to my array list people and I say people dot add w, it's going to let me add a worker. It's going to let me add a student, and it's going to let me add a person. Why? Because all these are actual people. Since they are extending from person, they can also be treated as person. Okay, so this is another use for polymorphism. Another thing about polymorphism, which is really nice, is that if I come and I say, let's print out this array list. Let's print out people, and let's just go to the worker class and add a toString method because we didn't do one. So public string toString. Let's just have it say string str. I am a worker. Let's just add our super dot toString. So we just want to indicate that it's a worker so that when we're printing them, we know. And let's go run this code. So we added a worker, a student, and a person. Let's see which toString methods is going to be called. So here, when I added the worker, the first object that got printed was I'm a worker and its name. And then when I wanted to add the student and I printed the student, it printed the student information. And then when I printed the person, it printed the person information. So what it did was it went to the toString method of the worker class, the toString method of the student class, and the toString method of the person class. it didn't treat them all as person. It didn't go and call the toString of person. It actually went and called the correct toString. It actually went the underlying code went to this W and said, W, I know you're in an array list of person objects, but you might not really be a person. What are you? And W said, I'm a worker. And so it went to the worker class and called the toString method in the worker class and printed I'm a worker. And then the next thing is it went to the S and it said, S, I know you're an array list of person objects, but what are you? What class do you really belong to? And S said, I am a student. So it went to the student class and it found the toString method of the student class and it printed it, which prints the super, which prints the name, and then it printed the banner ID. And so that's why we got the student. And finally, it went to the P and said, what are you? And it said, I'm a person. So it went to the person class and found the toString method of the person class, and it printed that. Okay. So here, this concept of going when you need to go and you call a method like the dot equals or the toString method, even though you are stored in a person array, or even if the reference, like even if all these just said person, okay, you're storing the variable as a person. This will give us the same result. Even if I make these all person, I still get the worker toString method, the student toString method, and the person toString method. This is called dynamic binding. At the time of implementation, here, this person W, we might not know what person W is going to be. In real life, here, it could be that, and then later in an if statement, like if, I don't know, if true, for example, you're talking to a user, and then you decide, well, you know what, the user is not a worker, they are actually a student. Okay, so at the time you're writing the code, you might not be able to determine what an object is really going to be, because maybe you're going to create something different depending on what the user tells you. So you ask them, are you a student or are you a worker? And based on what they tell you, you're going to create a different object. So if they tell you they're a student, you're going to create a student object. If they tell you they're a worker, you're going to create a worker object. And so here, I've just made it, even though here it's a worker, I actually made it a student. And so now we see that it's actually a student. So because at the time you're writing the code, you're writing some cases, but you don't know which part of the code will actually get executed. You don't know if this if statement will actually get run or not. So what's happening right now is called dynamic binding. At the time of running the code, dynamically, the Java runtime machine will determine which method it is appropriate to call. So based on the type of the W object, whatever it is, we know it's a person, but we don't know really what else it could be. So at the time of runtime, we will determine, the JVM will determine W is actually an instance of what class, and it will call the appropriate methods on that class. So this is called dynamic binding. Okay. And so here, these are examples that are similar to what we did. They're all legal polymorphic references. And we said the opposite is not possible. You can't have a child object and store in it a parent. Okay. And then we talked about dynamic binding, or also it's called lit, where you can determine at the time of runtime, Java, the Java virtual machine will determine what the object is, what type of object it is, and it will call the appropriate method on it. Now, what if you yourself want to write code that runs something different based on what the object is? So there are two ways you can write code that determines the type of an object. So one way is using the instance of it. This is the easier way of doing it. So you can go to an object and say, are you an instance of computer science student, or are you an instance of worker, or are you an instance of student? And if it is that class type, you will be able to do casting. You can do casting to it to cast it to that object. Another way you can do it is go to an object and say, tell me what class you are. get class. So get class is one of these methods that are available on an object from the object class. And then you say, are you equal to, and then you put the name of your class dot the word class. Like class is a keyword. So let's try these two. So here, let's say I have my array list and I want to invite like some people. Okay, so here I want to say, I want to go through my array list. So for every person, X in people, I want to only invite the students. So here we have 2 students and a person, right? So I'm going to say if X instance of student, okay, we don't put that out class, instance of student, then system.out.println found a student and let's say X. Okay, let's run this code. And so I'm going through every person and it's checking. So it's going to this W and saying, are you a student? And because here we have this if statement, which made it a student, it says, yeah, I'm a student. And so it printed it out. So it found student, new student. And then it went to the next one and it said, S, are you a student? And S is a student that we've created called cat. And so it prints it out. And then it goes to P and say, P, are you a student? And it says, no, I'm not a student. I'm a person object. And so it doesn't print it out. So you can use that to determine at runtime, if you have like an array list of different objects, you can determine what they are. Now, instead of using the if the instance of, what we could have also done was we could have said if X dot get class, your class is equal to the student dot class. And that should give us the same result. We're going to get only these two being printed out, those 2 students. Okay. Now, the nice thing about polymorphism and knowing that everything extends from object is that we can actually create array lists that store different objects. So I can just say, I want an array list of objects. And I can store any type of object in there. So I can go to objects and add, a worker, the worker object. I can go to objects and add a new integer, like a wrapper class. I can go to object, add a student, a string, sorry. I can add any object. I can go to object and add new scanner, system.in, and you can add any objects. And we need to import scanner. Let's import scanner. And so now I added all these and I want to print my array list. And now I have 4 things. I have my worker, my student in there, and then I have the number, so this is the worker, and then I have my number 10, the new integer that I added, and then I have my string, and then I have my Java, and I guess this is the toString of the Java. It's all this scanner. That's the scanner toString method. That's what it prints. And if you needed to, do something like a for loop, you could also do that. So for every object O in object, maybe I only wanted to print the strings. If O instance of string, system.out.println found a string. Oh, so here I can print my, only the string will get printed. Where did it go? It didn't get printed for some reason. So let's try to debug this. Let's try to see the, let's print here system.out.println object.getClass. Let's see the class of each one. Let's see what's going on. Okay, so here we have student, integer, string, and that. So it doesn't like that. Maybe I should say java.lang.string. Let's try that. Oh, instance of java.lang.string. Okay, I'm not sure why it's doing that. I'll have to debug it and show you, like figure out what's going on. Why is this not printing? Okay, but that's the idea of polymorphism, is that you can store different objects in with like referring in variables that are kind of like different types, but they're really not different types. They're the parent type. The other thing is dynamic binding that we talked about, is that when you have an object and you might not know what the underlying object is, like here I'm saying person, but if I call a method on P1, it will know that it is really a student, and it will go find the student methods and it will call those. And then the other thing we talked about is having array list of basically the parent object, like here, or here we had like just object, and things will work when you call the toString method. It will know which method to go call, in which class. So for the classwork for this part of the lecture, you are going to be creating a preferred customer class, which inherits customer. You will be building on your classwork from 10.1. And you're going to follow this, and you're going to overwrite some methods and use polymorphism and use the instance of to practice the concepts that we've learned in today's lecture.